Okay, chapter 7, we're going to start with graphing exponential growth functions. So again, take notes, pause when you need to pause, rewind if something didn't make sense. When I'm doing some computations, pause it and do the computations yourself to make sure that you understand them. Just don't copy down what I get for the y column. Make sure you know how to do it. So exponential functions are growth functions that grow, like deer population would be a growth function. Bacteria, how bacteria grows would also be an exponential growth function where they start out relatively small and they grow very quickly. So the basic one for exponential function is y equals a times b to the x. So the x is the exponent, the variable. And then a is positive. A also can be negative. But the thing that makes it an exponential growth function is that b, your base, is greater than 1. So b could be equal to 5/4. That's a number greater than 1. 3, 2, 10/3. Anything greater than 1 would be a growth function. Okay, if it was less than 1, it'd be a decay function. Right. So we're just going to graph just something basic so you can kind of see how it works. We're going to graph this one. So x, and our function is going to be y equals 3 times 2 to the x power. All right, so if we don't know what a graph looks like, we're just going to do a bunch of them. So we can do something like -4, -2, -1, 0. We can do a bunch more over here. We can continue this. We can also do +1, +2, +3. Okay, so go ahead and plug in -4. Let's see, and if you're not sure how to do that, watch me for the first one. So we have y equals 3. I'm not going to write the y equals part. So we have 3 times 2 to the -4 power. And then that is unhappy upstairs, so we're going to move this downstairs. So the 3 stays in the numerator. This becomes 3 over 2 to the 4th power. And so that is going to be 3, and then 2 to the 4th is 16. So 3/16. So something very, very small, close to 1. Right? Please do the rest by yourself. So pause the video and make sure you get what I get. So pause, do -2, -1, 0, 1, 2, and 3, please. So for -2, again, hopefully you're not listening to this right away because you paused the video. But order of operations, we're going to do 3, and then this is going to be 2 squared, so that's 3/4. So definitely less than 1, but greater than 3/16. 3 times 2 to the -1 is going to be 3 over 2 to the 1st, which is just 3/2 or 1.5. When we plug in 0, we have 3 times 2 to the 0. And remember to do order of operations first. So 2 to the 0, which anything to the 0 power is 1. So we have 3 times 1, which is 3. And then we have 3 times 2 to the 1st, which is going to be 6. And then we have 3 times 2 squared. So make sure you do order of operations first. So we square 2 and get 4, and 3 times 4 is 12. So you can see this grows very quickly. If we did 3 times 2 cubed, order of operations, we'd get 8 first, and then 3 times 8 is 24. So our growth function grows very, very quickly. Right? And then when we graph it, let's see, we have -4, something very close to 1. -2 is 3/4. -1 is 1.5, 0 is 3, 1 is 6, 2 is 12, so it's off the graph a little bit, and 3 is way off the graph. So it grows very, very quickly, And would we ever get a negative? Would our graph ever go this way? Is there any way I could plug in some number to get a negative so that this part of the graph would go below the x-axis? So what do you think? Would we ever get a negative? See, I could plug in a bunch of negative numbers, and I did here. So I plugged in -4 and -2 and -1, and the only thing that did was bring the base of 2 and the exponent in the denominator. So no matter what I plug in, I could plug in some negative numbers, and then we just move them downstairs. So there's no way I'm going to get a negative number. So when I draw my graph cannot go below the x-axis. So the domain for this one, again, I can plug in negative numbers, 0, and positive numbers for my x's. So the domain is going to be all real numbers. My range, however, the graph is not going to get lower than the x-axis. It's not even actually going to reach the x-axis. So the range is going to be greater than, so no line underneath, just greater than 0. So we have something that's called an asymptote at y equals 0. Okay, looks like an x. Y equals 0. So it's kind of like a magnetic force field pulling the graph towards itself, if you want to think of it that way. Or the graph is giving the asymptote a big hug. So just keep that in mind when you're drawing your asymptotes. Okay, and then here's the very basic one. This is the very basic graph. F of x equals b to the x. So pause this, read through it. Make sure you know what domain and range is, what the asymptote is. Okay. And then here's another example. So this part doesn't have an a. So we're going to graph y equals 2 to the x. So we can use -2, -1, 0, 1, 2. Normally, when we graph, we just usually use 0 and 1. So as soon as we know the basic shape, those are the only two numbers you really have to use. But until we get more comfortable, we'll use all the numbers. So please pause the video and get the y values for yourself. Pause the video and get all the y values for yourself, please. Okay. 2 to the -2, hopefully you did 1 over 2 squared, and you would get 1/4. 2 to the -1, you move that downstairs, so it's 1 over 2 to the first power, which is 1/2. Right, when you plug in 0, 2 to the 0 is just 1. 2 to the first is 2, and 2 squared is 4. Okay, our asymptote is going to be right here on the x-axis at y equals 0. Okay. And then when we graph it, we have -2 and 1/4, so something really close to 0. -1 is 1/2. 0 is 1, so this will be 1. 1 is +2, and then 2 is 4, so that would be 2, 3, 4. So right up here. So it gets super, super close to the asymptote, but never crosses it or touches it. So you have something that looks like that. And then our domain is going to be all real numbers. Our range is going to be y is greater than 0. All right. Okay. And then we can graph this one, these two examples. So again, make sure you do order of operations. So we can shorten it a little bit. Let's do -1, 0, 1, and 2. Okay. Again, when we get the basic shape down, we can just use 0 and 1. That should be fine. Okay. So pause the video, do these yourself, and get the y values. So pause the video right now. Just pause. You can do it. Okay. We have 1/2 times 4 to the -1. So It's going to be 1/2, and then this is going to be 1 over 4. So that would be 1 over 8. 1/2 times 4 to the 0. Order of operations, we do that first. So 4 to the 0 is 1. So we have 1/2 times 1, which is 1/2. 1/2 times 4 to the first. That's going to be 1/2 times 4 over 1. If I turn it into a fraction, then we multiply the top with the top and the bottom with the bottom, and we get 4 over 2, which is 2. Then we have 1/2 times 4 squared, which is 1/2 times 16. So half of 16 is 8. So again, a growth function grows very quickly. All right, so when we graph that, -1 and 1/8 is right about there. 0 and 1/2. 1, 2, and 2, 8. Okay. All right, and then go ahead and draw the asymptote on your paper before I do it. Draw the asymptote. So if you drew it right here at the x-axis, you are awesome. That's where my asymptote is. So my graph is going to get very, very close to the asymptote, like it's giving it a big hug, and then it's going to go straight up because it's a growth function. It's going to go very quickly. And then please write the domain and range all by your lonesome. You can do it. If you put domain as all real numbers and the range is greater than with no line underneath, greater than 0, good job. That is the domain and range for this one. Okay, the negative is going to be a little different, but we can still do it. All right, so we can plug in -1, 0, 1, and 2. Again, when we have the general shape, all we need is 0 and 1. Okay, so go ahead and plug this in. Get your y values. Pause the video. Pause it right now. And get your y values. Go ahead. And then we have -1 times 5 to the -1 power. All right, so that negative out in front, that's like a -1. Okay, so order of operations, we're going to do this part first and then multiply by -1. And this is the same thing as 5 to the -1 power over 2 to the -1 power. So they're both unhappy living upstairs and downstairs, so we're going to switch that. So this becomes -1 times 2 to the first over 5 to the first. Right, and then that's 2 over 5. -1 times 2 over 5 is going to be, this is going to be equal to -2/5. Okay, so a little less than -1. So if you weren't sure how to do it, that's how you do -1. So please pause the video and do the rest. You can do it right now. And then hopefully for -1, or for 0, you got -1 times 5 over 2 to the 0 power. And that is equal to -1 times 1, which is -1. All right. When you plug in 5/2 to the first power, that's going to be -1 times 5 over 2, which is the same thing as -5/2. So that's -2.5 if you like decimals. And then when we plug in 2 for our exponent, we have 5 over 2 squared, which is the same thing as -1 times 5 squared over 2 squared, which is the same thing as -1 times 25 over 4, and that's the same thing as -25/4. So 24 divided by 4 is 6. So -24 divided by 4 is -6, so it's a little more than that. All right, so when we graph these, so check your answers. Hopefully, if you found all these answers, fast forward the video, check to make sure you have all these answers. If you don't, then please rewind the video because I did explain how to do them. Okay, those was what you should get. If you don't get that, rewind the video and look at how I worked it out. Okay, all right, and draw your asymptote on the graph. If you drew it right at the x-axis, you are awesome. That is the asymptote. And then when we draw our points, let's see, at -1, we got -2.5. So below, 0 and -1 is right here. 1 and -5/2, that's -2.5. And -2, that's off our graph right here. So with the negative, the graph reflects on the x-axis. So it's growing fast this way, and it's coming up to the asymptote and giving it a big hug. So think of that asymptote as a magnetic force field pulling the graph to itself. And then please write the domain and range. All right, before I do, write the domain and range. Okay, and hopefully you put all real numbers. And hopefully this changes a little bit. It is going to be y is strictly less than 0, because now you're graphing all negative numbers. The y values are all negative. All right, so if you did that all by your lonesome, good job. Now our friends are back, the friends that never leave. So please write this down. Y equals a times b to the x minus h plus k. So remember, h is the BFF, h is the best friend, so that is the one closest to the variable of x. Okay. All right, so a opens up or down. H is horizontal, so H for horizontal, and that is the opposite. Remember, it's the opposite, and K never changes, it's the same. And it's the vertical shift. Okay, so to create a graph, remember we said x equals 0 and 1. Once we know what it looks like, we can just use 0 and 1. So please pause this, write this down. Okay, we're going to create a t-chart, and we're just going to graph this part. Just like we did on square roots and cube roots, it's the same idea. Okay. Then we're going to translate and draw the asymptote. So our asymptote, instead of being y equals 0, now it's y equals k. Right? And then we're going to translate the points from the t-chart using h and k. So our 2 points, we're going to translate them and then draw the graph to the line y equals k. So please take time, write this down. Very important. Okay, write it down. Okay, so now we're going to figure out if you know what h and k is. So for this one, write down h and write down k. So if you said h was +1 and k was equal to -2, you rock. All right. All right, for this one, please write down what h and k are. Write it down. You don't even have to write down the function, just write down h and k. This is your test. All right, if you should have put h equals -1 and k equals -2. So if you did that all by your lonesome, you are awesome. Right, for this one, please write down what h is and write down what k is. So if you notice h, there is no h. Okay, the exponent is all by its lonesome. So there's no best friend. H is equal to 0, and then k is equal to 2. So our asymptote is at y equals 2, and we're just going to shift, if we were graphing this, we'd shift all the points up 2. No horizontal shift. Okay, for this one, please write down h and k. Write down h and k, please. Okay, so hopefully you said h was -1, because it is in the exponent, and so if there's a number in the exponent, then that's the best friend, that's h, and k is equal to 0. So all we are going to do if we graph this one would shift everything back 1 horizontally. Okay. Okay, so now let's practice. We've got this one, write this down, y equals 4 times 2 to the x minus 1 minus 3. So both friends are there. So step 1, we are just going to graph this part. That's all we're going to do. So since we practiced that, please pause the video and graph it yourself. If you need more points, use them. If not, 0 and 1 are fine. So find these points, graph them, pause. Okay. All right. If you did that, then you can fast forward till you see the answer. If it didn't make sense to you, then rewind it and you can take a look at this. But this is 2 to the 0. We're going to do order of operations first. exponents first before we multiply. So 2 to the 0 is 1. 4 times 1 is 4. 4 times 2 to the first, we're going to do order of operations. So that would be 8. Okay. So let's see, I've got 0, comma 4, 1, comma 8. And I know it's going to look like this. Okay. All right, so that's step 1. Step 2 is to translate the asymptote. So let's figure out what h and k are. H is positive 1, and k is going to be negative 3. So our new asymptote, our new boundary is y equals negative 3. So right here. Okay. All right, now we're going to shift. So we're going to take each point. So I'll take the 0, 4 point, and we're going to go over 1, down 3. 1, 2, 3. And then over 1 again and down 3. 1, 2, 3. And then remember, the asymptote is a force field. So we are going to get really, really close to the asymptote without going over. And our green graph is our new graph. And then for domain and range, domain is still all real numbers. And our range is going to change to be greater than our asymptote. So of negative 3. So range is greater than negative 3. Okay. All right, so for these ones, let's see, you can completely do 1, 2, and 3. Okay, so for number 3, make sure you graph, oops, I got rid of the X somehow. All right, so for number 3, just make sure you graph this part first, and then translate with H and K. Okay. We're going to skip 4 and 5. So for chapter 7, we're going to do things a little bit differently. So please make sure you're following the notes. So we're going to skip 4 and 5. And then we're going to do compound interest. So this should look familiar from our credit card project. But if you don't remember those notes, we have A is the amount after, P is the principal, right? So if you put 5,000 in the bank, that would be your principal. R is your rate, and that's expressed as a decimal. So if it was 40%, your decimal would be 0.4. If it was 4%, it would be 0.04. N is times per year. A is the amount after. And T is time in years. Okay. Right, and that is our formula. So for this example, pause it. Well, don't pause it yet. First, put it into this formula. So figure out what the principal is, the rate, what the N is, and T, and see if you can plug everything in for part A into this. Okay. So pause it and do that now. Put P in, put R in, put N in, put T in. Okay. So for quarterly, that would be 4 times per year. Our principal is 4,000. And then this is 1 plus our rate. Let's see, this is 2.92%. So we're going to move over the decimal twice. So our rate would be 0.0292. N is 4. And then we're going to leave it for 1 year. So this would be 4 times 1. Okay. And then in your calculator, you would get 4,000 times 1.0073 to the 4th power. Again, make sure you do order of operations. So you're going to do this first, and then multiply by 4,000. And so you should get this. approximately that. So that's for quarterly. For daily, the only thing that's going to change is n, and daily is going to be 300, n is going to be 365. So pause the video and plug it in, and when you get your answer, fast forward to my answer. If you don't get the answer, rewind it and take a look at what I did. But do that right now, all by your lonesome. Go for it. Okay. And then if you didn't get the answer, let's see. N is equal to 365, so when I set this up, my amount is going to be 4,000 times 1 plus 0.0292 divided by 4, and that's going to be 365 days times 1 year. Okay. So then this is going to be 4,000, and when you simplify the inside, it's going to be 1.4 zeros and an 8 raised to the 365th power. Now when you do that, you should get approximately this. So let's see, did it help? Well, you made a little bit more, 52 cents opposed to 9 cents. But that's how interest compounds. Okay. All right. And then for number 6, you can totally do that, but instead of time being 1 year, now it's going to be 3 years. And it's going to be compounded daily, so it's like example B. And that is the end of this lesson.